Where's the
Down to the right.
No, the Meagle.
Right here. We were having a conversation earlier.
Oh, okay, I got you.
Just talk to you.
I was talking to my Meagle just the other day. He said he was upset and was gonna fly away. I said, Mr. Meagle, please stay with me. If you do, I promise that you'll be happy. La 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 la.
Oh. I'm sorry, I'm tired.
You're okay.
Oh,
I think
that's what I wanna
everybody today is so tired. I'm just like, yep.
huh?
Everybody today is just so tired. I'm just like, yep.
I know, but I have to work all weekend. And that's fine.
Yeah, I just. I'm not ready.
I'm not excited about that. About putting in food. I had it. Today we were allowed to shampoo inside each other's hair, and they got shampooed my hair. I accidentally got it. It was soaked. But it's okay because my hair smells and feels amazing. Dude, I like chewing on your You see my headphone. Is it just me or did you just like it fly past the door?
Yeah, I do.
I thought it was like a balloon.
Do you understand any of what this is?
What?
Do you understand any of it?
Like the one we're born?
Yeah. Any of it?
No. I got halfway done the class.
You're good.
Hey, Brooklyn.
Well, like, that's the thing that I asked you. I just put it in like one of the like.
I will be
You guys are pigs, man. Come on, stop. Hi, Yusuf. I know you can hear me. I can't hear you, though. All right. Welcome back, guys. It's Friday. It's Friday. And we're going to go over the homework, and then we're going to do a lesson on solving exponential and logarithmic equations. Yes, 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 yes. Woo! So, take out your homework. We'll start going over that. And let's see here. I better start my video for you. Yusuf. Oh, I was sharing my screen so you can see that. So the answers I'm going to put up there are the book answers. So there's like a program we had that would, you could just tell it what numbers you wanted. And I put in number 8 as well. So you're going to see an answer for number 8. Doesn't matter, just to skip it. You didn't have to do that one. Skippity, skippity, skippity doo. Ka-chow. All right. You go view, read mode. There we go. All right. So you can see question, answer, and then this is like actually the solution as to how the answer was achieved. So you're looking here to see if you have the right answer or not. You can skip 8 because we didn't have a number 8. Okay. Scroll up a little bit here. You should. Oh, I like that blue. That's kind of pretty. Boop. Okay. Shubbity bobbity boo. And I'll show you all the answers, and then we will do any of the problemos you want to do. Guess what? I'm in a good mood today, actually. I'm not in a bad mood like I usually am.
You're in a bad mood.
Oh, can't you always tell when I'm in a bad mood?
No.
No, you're right, because I'm not usually in bad moods. Because why would I want to be in a bad mood when I can choose to be in a good mood? So much more enjoyable to be in a good mood than a bad mood. Bad moods aren't fun for anybody, included. Hey.
It sounds like you're starting to hear.
Woo!
It's the birth year, that's why you're.
Okay, is everybody done with the first page? They've checked? Okay, let's go here. Shabba-ba-na. Shabba-ba-na. Oh, no!
Students and staff, pardon the interruption. At this time, we need all freshmen with last names A through K who are getting picture retakes to go to the auditorium lobby. Again, that's all 9th graders with last names A through K who are getting their pictures retaken. Go to the auditorium lobby. Thank you.
Ciao. Okay. Did-a-bop shibba-doo. Did-it-did-did-did-did-ya. Jabbity-bubbity-boo. Shrunk-dun-diddy. Did-it-did-it-ba. Oh, yes. Buddy. Okay, and number 70. Shabba-ba. Fun. Yo-yos are fun. Okay. So we will now do any of the problems that you want to do. So who wants a problem from last night's homework done? Anybody? Anybody? Yeah.
Can we do 16 through 32?
All of them?
Not all of them, but I meant like, well, like 16, 23, 29, and 32.
All of them.
Yeah.
Gee, Hamza, I don't know if I have that much ink. All right. We'll try. Oh, you can run out of ink on a smartboard. Just kidding. I'm just kidding. You said 16 through 32.
Yeah.
Expand the expression.
Oh, yeah, I got that one wrong.
16 was the natural log of 15x. And I know what you may have done. I don't know. Okay. So, and I told you that this is the natural log. I would like that better, right? Of course. It's the product property, right? So, now, if you want, could you go further than that? Could you make it this? ln3 plus ln5 plus lnx if you wanted to. Could you go that far if you wanted? You could. I don't know if they did or not, did they? No, they left it as 15. They left the number as a number. Did you do this by any chance? Say, yeah, Hans, and then you'd be like, yeah, I did that. That's what I thought.
Yeah.
Then you did it great. I'm just kidding. No, are you okay?
Yeah. I just got confused with the natural log.
Oh, it's just natural log. Yeah. Log base E. ln, natural log nectarino. Yeah. Want me to do the other ones too?
Yeah.
Sure, all of them?
Yeah.
All right. Let's do that one. So what's the next one here? 23. 23. Log base 7, 5x squared, yz cubed. 5x, what is it again? Log base 7 of 5x yz squared?
Yeah.
All right. Oh, I don't want to narrow. So on this one, I'm multiplying 1, 2, 3, 4 things. So that means I'm going to be able to add 4 logarithms together. I'm just going to jump straight down. So if I did that, it would be log base 7 of 5, log base 7 of x cubed, log base 7 of y, plus log base 7 of z squared. And then power property, this one stays what it is. 3 times log base 7 of x. What's your power? How's that look, Hamza? You okay with that one?
Yeah.
Okay. Next one is number what?
29.
29. I asked you for 29. Cool. Natural log of the 4th root of x cubed. How's that look? So what I do, rewrote from the radical to a rational exponent, power to power property, boom, power of a product property or power of a logarithm, power property of a logarithm, boom, bam, slam. Questions on that one, Hamza? If you do, just ask.
Okay.
Are you okay with that one?
Yep.
Okay. And then I also asked you for 30?
32.
Oh, 32. Oh, yeah. I'm in a really good mood today. Natural log of 8x cubed. And they said that that was equal to 3 ln 8 Okay, so, and this is indeed wrong. A strike. Okay, on Family Feud, that's a strike. Because, first of all, this is the natural log of this entire thing. That exponent of 3 goes with the x. So if I expand these to start, this would be the natural log of 8 plus the natural log of x cubed. So that 3 only goes out in front of this logarithm here. So it should be the natural log of 8 plus 3 times the natural log of x. I just put it in front of the wrong one. It shouldn't be in front of the natural log of 8 because 8 is not to the third power. Just x is to the third power. Thank you very much. Anyone else got some questiones? Yep.
62.
62? Are you kidding me?
Sounds like you're getting in a bad mood there.
I'm not. Find you want all 3 of those? Or you just want like one as an example? Is there a certain one you want?
Just do one.
Okay, so all of these are using the same formula, which is this guy right here. It said to look back at example 5, and example 5 gives you this, where this is the sound in decibels, okay? Loudness based upon intensity is the sound in decibels. This is the intensity of the noise, 10, common log, and this is the intensity of, like they said, a barely audible whisper is what they said it was. So they gave that to you on whatever page it was. So, part A says, hey, a barking dog, which has an intensity of 10 to the negative 4. That's what they tell us. And they're asking us to take that and turn that into decibels. All right, we can do that. So I plug it in. So this right here, okay, is equal to 10 times the common log of the top, 10 to the negative 4 over. This always stays the same in this problem. And this becomes 10 times the common log of laws of exponents. What do I get there? 10 to the negative 4 minus negative 12, which is 10 to the positive 8 power. We should know that when the base of the logarithm and this base are the same, they cancel out. So what do I get here? 8. So I get 10 times 8, which is 80 decibels. We get your cow. They're all done the same way. All done the same way. So that's how you would do on letter B. L would be 10 to the 0, and letter C, it's 10 to the negative 6.5. And you're just evaluating over there.
What was the answer to 38?
38?
No, I just mean what's the answer?
I'm telling you. Log base 4 of 32x to the 7th, y to the 4th. You have that? Would you like to see that? It's okay if you do.
Sure.
Okay, we're going to do that one. Here we go. Number 38. Log base, 5 log base 4 of 2. And then the next part is plus 7 log base 4 of x. then 4 log base 4 of y. So when you look at this, we're going to just condense 2 at a time. So if I start with these, first is, actually what I'm going to do on this, let me rephrase that. I want to go ahead and take care of all power properties of logarithms to start. So that means this 5 is going to go up here, this 7 is going to go up here, and this 4 is going to go up there. That's where I'm going to start this at. Rewrite it. Log base 4 of 2 to the 5th plus log base 4 of x to the 7th and log base 4 of y to the 4th. Now we'll condense it. Product property, log base 4 of 2 to the 5th times x to the 7th plus log base 4 of y to the 4th. And then the last one, condense those. Log base 4 of 2 to the 5th, they actually just multiplied it out. That is the 32 x to the 7th. White close. You okay with that, Abby? If you're not, you just need to say so. Okay. You understand what happened here? From here to here? So this part we're good.
Yeah.
What about from here to here? Are you okay? Okay. So I took these and I used the product property, which says log base b of x plus log base b of y is equal to log base b of x times y. So that's what I did here. I took these, it's the logarithm of their product. Then I brought the next one down. Then I did the exact same thing again from here to here. It's going to be, since they have the same logarithm and I'm adding them, it's the logarithm of the product of those things. Is that okay now? Mm-hmm. Cool. Anybody else? Okay. Well, I'm thinking we should start doing some solving equations by hand. Exact answers. So you really won't even need a calculator. We're just going to get exact answers for right now. Exact answers. So let me. What in the world is this? Is like, what's going on here? Let's just start a new log page. Anybody got any big plans this weekend? Working?
I actually don't know.
You guys better get out your warm clothing. It's going to be cold next week.
We're staying in the house.
Of course, the coldest morning, I think it's going to be Saturday morning, -8.
What?
Great. My car was stuck.
Okay, so that means that Sunday is going to be cold.
All right. Woo! Here we go. Let's get ready to do math.
Oh,
I know, you thought I was going to say rumble.
yeah.
But that's a fighting, and I get expelled for that. Okay, so our job today is to solve exponential and logarithmic or logarithmic. You don't want to say the A, I'm cool with that. Equaciones. Okay, so we're going to be solving exponential and logarithmic equations. How will you recognize an exponential equation?
Wait,
The exponent will have a variable of some type in it. That's an exponential function, is 2 to the x, right? So it's going to have a variable in the exponent. That's an exponential equation. A logarithmic equation, I'll bet it'll be written as a log. Great. Okay, now, can anybody tell me exponential functions and logarithmic functions are what types of functions? Inverse functions. So usually when I'm solving exponential functions, I will incorporate or use logarithms. And usually when I'm solving logarithmic equations, I will incorporate and use exponential. Notice I said usually. You do not always have to do that. There are some special cases where you will not need to solve an exponential using logarithms. And there are some where you will not have to solve a logarithmic equation using exponents. We're going to start with some of those. Those are the easiest ones of all to deal with. Okay? So here we go. I'm going to just put something up on the board, and I want you guys to just fill this in for me. Okay? So if, you don't have to write this down. This is just to get your mind working in the right order. What should I put in those two blanks? What? Yeah, then B equals C. If you have two bases to exponents, the exponents have to be the same. That's just, I hope, common sense. Now, that would be the easiest type of exponential function to work with. That would be the one that looks like this. 2 to the x equals 2 to the 2x plus 3. These are both exponential. But I don't have to use logarithms to solve it. If they have the same base, then all I have to do is say, well, if the bases are the same, then what's true? X has to be equal to 2x plus 3. I would just say, oh, x equals 2x plus 3. Did I use logarithms at all? Nah, I didn't have to. Subtract 2x. Woo, woo. Negative x equals 3. So x, of course, equals. Is it okay to have a negative value in an exponent?
Yes.
Yes, it's okay. So that's a good answer. Good, we're done. That's the ones, if I give you, you should be like, yes, I can do this one. Okay? All right. Now, on the same kind of level of that would be this type of problem. So I asked you this. So I did this, and you guys did really well with that. Beautiful. What if I did this up here? Anybody say it?
X equals Y.
Yeah, right? If I have two logarithms equal to each other and they're in the same base, then these values are going to have to be the same as well. So the easiest type of logarithmic equation that I could give you would be something on the order of this. Oh. Because in a problem like that, I could say, oh, well, those are both common logarithms. I don't have to even worry about that. I could simply do what? Set 3x plus 1 equal to 2x plus 12, and then solve those. Does it work in the original equation? Yes. It gives back positive values here. What do I get here? 34. What do I get there? 34. Those are the easiest ones of all. You don't have to do anything exponentially really or logarithmic. It's basically what? Linear equations you're solving there. Those are the easy ones, okay? We're going to go one step harder than that. Okay, here we go. So let's go ahead and go up one step in difficulty. We're going to solve this one. Oops. Yeah. All right, so we look at it. And my immediate response is the bases aren't the same. But my first question myself is, am I capable of rewriting them so the bases are the? And the answer is yes. I can rewrite 49 and make this what? So I get 7 squared to the 2x plus 1 equals 7 to the 3x plus 4. And lo and behold, what's rearing its ugly head again? Power of a power. It's back. There it is. So now I have to say 7 to the 3x plus 4 equals 7 to the, yeah, 4x plus 2. Because I have to do what? Distribute it through. Most common mistake here is make this 4x plus 1 and forget the distribution. Now I can just set the exponents equal. Bloop, bloop. Minus 3x, minus 3x, minus 2, minus 2, electric boogaloo, 2 is equal to x. Done. Got it. Okay. So that's is that a little bit harder? Yeah, just a little. I had to just be able to say, oh, 49 can be 7 squared. And I have to know power of a power. Okay. Let me check these problems off as I'm doing them here. I wrote these down earlier. Check, check, check. Now this next one's going to look worse. We're just getting progressively a little more difficult. What?
Like the problem with the last one, what if it doesn't like when you get squared like so easily? Or like
Oh, here, let me go ahead and wait. Are you saying something like this?
I bet you 10 to 1 you just said is next problem.
That?
What have you done?
That's the next problem on my sheet. 11 to the 5x equals 33. And now, rewriting 11 and 33 so they have the same base, probably not a real easy thing to do because 11 is a prime, right? I could write 33 as 3 times 11 if I wanted, right? I could do that. But let's not make this complicated. Okay? First thing I want to, how is this different than the other ones? The biggest difference is here, both exponents had the variable x in them. This one doesn't. I'm not going to waste my time with that. I'm just going to rewrite it as a logarithm. This would be log base 11 of 33 equals 5x. Oh my goodness. All I have to do now is divide both sides by 5. Here's your answer. X equals log base 11 of 33 divided by 5. That is an exact answer. That's it. That is an answer. Do I have to go any further than that? No. I can leave it like that. If it's a problem now where it says, hey, round your answer to the nearest blah, 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 then yeah, you have to go ahead and use a calculator to get a decimal equivalent roughly and give me the answer. But this is beautiful. So that's not really hard at all, is it? Just write it as a logarithm, and I was basically almost done. Look at that. Mitter! Not you, that one. Yeah. What student's name do you need now?
Marie is going to Italy.
Oh, cool. Wonder what kind of souvenirs we're going to get from there.
I don't know. I'm already trying to book flights. Like it's a town that's about an hour west of Venice. Like almost in the mountains.
Wouldn't that be rough?
Yeah.
She
was second in her class.
How long? She was second in her class.
So
How long is
showed me this video, like where all of the seniors are in this room and they call the cadets up one at a time. So, and they go up to this board and they pick where they want to
The
go.
placement where they want to go?
Yeah, and she gets to go second.
Wonder how long that's for.
How many friends have
2, us. So how long is that?
I don't know, but there's this thing, I saw on TV the other night. There's a 10-day or 9-day hike around Mont Blanc.
Mm-hmm.
It's called the Tour de Mont Blanc. It's a pretty doable. Like it's not like you're climbing Mount Everest or anything.
Right.
I want to do that. I saw that and I'm like, oh.
Is there a discount for math teachers?
Well, I don't know.
Let's find out.
But the distance from where Marie is going to be living to where Mont Blanc is about 4.5 hours. So I'm like, if she could just find us a place to stay. I can fly there. Basically do that. If I can convince one person.
You know, my
to
friend, my brother-in-law in Texas, Steve Oliveri,
Yeah.
he's got family in Italy. I'm not sure exactly where they live, but
Italy's huge. I never realized how big it was.
it's a lot bigger than you think it
I know.
is.
Just looks like that little boot. It's a little boot. But
Child-sized boot.
Then someone in the family, I would gladly do it.
You don't want to go to Italy.
Why not?
Because you don't want to. All right, because COVID. That's why. Okay, so
Because COVID.
so this type here, not a difficult problem. Just think it through. Again, if you have a base to an exponent with a variable equal to some number, it's just write it as a logarithm and get on with your business in life. I'm giving you all these easy ones first because the harder ones are going to show up. Let's do this one. This is not that much more difficult. It's a little bit more, but not a ton.
Oh. Oh. That's easy.
All right, so this is really and truly a lot like the last one. But unfortunately, people freak out because they see the letter E and they go, this has got two variables in it. Yeah, it's the natural number, guys. So now look, on the last one, I was able to go straight to writing it as a logarithm. I could write it as a logarithm because I had a base raised to an exponent, all by itself on one side of the equation. I don't here. This 3 is in my way. So I have two choices. Actually, I have one choice. My best choice is just to get rid of this 3 being multiplied by e to the negative 2x. I think I'm going to undo this multiplication by dividing my sides by 3. So what I have to do is I have to start off by getting this isolated. Get it by itself on one side of the equation. Once I've done that, now I can go log mode on this. That's kind of like beast mode in math, okay? I can go log mode. Now I can write it as a logarithm. Now, do not write log base e. Exactly, because we're going to write what? ln for the natural log. Do I put an e down here still? No, it's understood that this is log base e. So it's log base e, or natural log of 6 equals. Now what? Divide both sides by? There it is. Okay. So far, so good. So goodly. So far, so goodly. Now, if somebody went ahead and took that and said, oh, well, Mr. Schneider, that'd be the natural log of negative 3, what probably would happen?
They would get slapped.
I would probably have to go over there and grab the what? Sort of knowledge. Because two things would be wrong with that. One, you cannot divide this number by a number here. And then if I did, I'd get the natural log of a negative number, which we know you're not allowed to do. All right. Now, what if, though, some smart aleck, like some kid I know named Yusef, what if he decided to write his answer like this? Is he smart? Is he a smart aleck? What is he? And I've got Yusef's muted, so I can't hear him right now. Tell me, is Yusef good or bad with his red math skills there?
I'm going to say this right now. He's just used to it.
What do you think?
I'm sort of thinking
What do you think?
It's okay.
You think Yusef's good? You think that he's right?
no.
What do you think?
I think it's right.
You think it's right? Are you guessing? Okay. Ollie, what do you think? Yeah, I don't know. Sarah. Savannah. Sure, it's right, she says convincingly. Davinen. You don't think it's right. Maddie. Abby.
I said yeah.
Oh, that's right. You said that already. Sorry, I didn't mean to ask you twice. Rachel.
It's one of those like trick questions. I feel like if you put it up there, it has to be right. I don't think-
Yeah, because I would always give you an answer that's right because that's just the way I am. Wrong, but that's okay. You can say you think it's right. That's fine. Hey, Timothy.
Something looks off about it, but I'm not sure what.
Okay. Chloe.
I don't know. It doesn't really look right, but it might.
Might be. You don't know. Lane. No.
Well, you said Yusuf was a smart aleck, so I'm thinking that is a way you can write it, but it's like a cheap way to write it.
Oh, wow. Alexander.
Well, the way I'm looking at it,
Uh-huh.
I'm wondering how in the world they got a square root.
Yeah, I know. Isn't that crazy? But it is Yusuf.
Maybe you should ask him himself.
All right, look, we're going to ask Yusuf. Yusuf, what do you think?
Oh, I'm not sure really.
You're not sure?
Yeah, I'm not sure if I'm
Then
right.
why'd you write that down?
I never wrote that down.
Okay, here we go.
What the hell is that?
It's because I'm streaming Zoom through YouTube, so we're hearing them both.
Oh.
Okay, that's why. So,
we can maybe actually hear what we're talking about.
yeah, I know, isn't that kind of creepy? So here, I'm going to tell you right now that Yusuf was challenging me.
Ooh. Ooh.
Here's what Yusuf did. Up to the 6 over -2. He said that's the same as -1/2 times the natural log of 6, which is the natural log of 6 to the -1/2 power, which would be the natural log of 1 over 6 to the 1/2 power, which would be the natural log of 1 over the square root of 6. Yusuf, you are so smart.
Oh yeah.
I need a response to that. I know your answer is yes, I am.
Yeah, I knew I was right.
All right. Isn't that beautiful? They're the same thing.
My head hurts.
Love it. This and this are equal to one another. All right, now. Hey, I'm just saying. So often when you give exact answers, here's the reason I'm saying this. If I have you solve something and I want an exact answer, there's a chance that your exact answers won't look exactly the same. Case in point, this and this do not look exactly the same, but they are equivalent to one another. So understand that in here. I might do a problem, like let's say I give you guys some homework problems, and I say, find exact answers. We come in, I do one. When I'm done, mine might look a little different than yours. Okay? Now, what does this mean? It's very important that you show what you're doing so I'll know if yours is good or not. Sometimes I can look at it and say, yeah, it's the same. Sometimes I'm going to need to see your work to see if you've done everything correctly to get to an answer that is equivalent to mine. So show your work. All right. Woo-hoo-hoo-hoo. Woo-hoo-hoo. What time? Where are we at? 25? Oh man, we got 2 minutes left. I'm just going to put the next one up there. This next one's really not that bad. It's pretty much child's play. Kind of like taking blocks and just stacking them one on top of the other. Dude. Okay, now.
Oh,
So you're going to start looking at this one, and this will probably take us into our break. And I want everybody to write down what you believe your first step is in this. And there are multiple first steps in this problem possible. And then I'm going to ask some people what their first step was. I'm looking. Why are you looking at me? Stop. Come here. Next time you look, he attacks. Don't look. Don't keep your head down. You make eye contact with him. Mortimer does not like having eye contact.
What?
Who?
Mortimer.
Mortimer?
That's his name.
Mortimer the Beagle?
Where's the
Bald
beagle?
Eagle Mortimer. Yes.
Where's his cousin?
He's out flying around right now looking for something to eat.
I'm lost.
Take a break. When you come back, we're going to go ahead and see what your first step was on this. I wish I could just stop being so nice and happy in class. I need to start being more of an ogre and be mean and yell a lot.
Please don't do
You need a
that.
brain break.
Mean?
You want to know what my teacher did
You
today?
need air.
Which one?
My CTC teacher.
What'd they do?
He just got up and left the school.
He quit?
Like, he didn't quit, but he just quit for the day. Like, he
What?
just got up and left. Yeah.
Who do you have? What is that?
He's Mr. Owen.
Oh, this is your Centerville teacher.
Yeah.
He literally walked out of the.
He literally got up.
How far in the class was this?
Like,
Did you do there 3 periods or 2?
it's 2. But, like, I use the third one to come back here.
That's right.
It was, like, probably, like, 20 minutes in.
To the
And
first period?
Yeah, but this is what happened. So he's like, okay, I'm going to go. I'll be right back. So he left and for, like, 20 minutes or so, and then came back and just, like, grabbed his stuff and left. And I even said bye to him.
Maybe
but,
did a sub or did anybody else come in to watch the class?
yeah.
Oh, so maybe he wasn't feeling good.
I think he was sad. Because I tried to say hi to him and he just ignored me.
Well, maybe something bad happened. So it could be bad.
I know, so I was trying to say hi.
You know what I want? I wish that my room had like a mirror there that was a 2-way, like a 1-way window that I could leave the classroom and just stand out there and watch you guys. I say, hey guys, I want you to try this problem. And I go, I'll be right back. And I leave and I just stand and watch you guys and see if you're working or not.
That would suck.
That'd be so much fun.
That would suck.
There's a teacher that did that with the test. She like gave him the test and then she walked out and then she climbed up in the tiles.
What?
Moved one of them and was watching them.
That's creepy. I would just set my camera up in here.
That's a ball of
And
You
watching
guys-
from a one-way mirror is not creepy.
Well, but you guys would know that's there probably. So you would
Yeah.
just say he's out there or he's not out there. That's the question. And then you wouldn't know. There you
We would
go.
always assume. it
See,
was-
maybe my bald eagle has a camera for one of an eye. Maybe one of his eyes is a a camera. And maybe he's actually recording your every move. Could be, you never know. And maybe I share that with the administration at the end of the day because one of my kids in here is a troublemaker.
Who's that?
I don't know. Who's the bald eagle always focused at?
You? Oh, wait, never mind.
Oh! Hello? What's your name, Miss Peyton?
I'm just snooping in.
You're snooping?
Yeah,
You snooping, doggy dog?
I know. This morning I park in front of my house on the street, and I'm like all ready to go, having a great morning.
You fell.
No, actually not this time. This time I have to go put my car in reverse because I park right in front of my dad's car, but I have to back up first and then drive off. So I start to back up and my car stops and you can hear my tires spinning, but it won't go. So I'm like, what? So I get out and there's like this piece of ice under
This is
my
what I'm
tire.
gonna do.
So I just took a
I
shovel
already
and
know what I'm
like
gonna
got
do.
rid of it, get back into my car, and it still wouldn't let me go. And it's like 6:42 and I had to be at school by 7.
What?
So I ran back inside and our driveway was like pure ice.
Oh, it was bad this morning.
So I told my dad, I was like, hey, I can't get my car unstuck. Or, because he has a Honda too. So I was like, are your keys up on the counter? And he goes, my Honda's dead. I was like, oh my gosh. So he comes out, he puts it in drive and like inches forward. And all of a sudden he looks at me and I look at him and he goes reverse and steps on the gas pedal. And my car went flying back and this chunk of ice under my car went flying to the street. I really thought that I was going to be stuck at home today.
That'd have been terrible. You would have had to watch me live on
Oh, that would have
YouTube.
been horrible. Honestly, I'm not even gonna lie, I probably would have been taking naps all day, because I need to catch up on some sleep.
Oh. You got a bowling match this weekend?
No, I work all weekend.
When's your next bowling match?
That's a good question. Like match or tournaments?
Just match, not a tournament yet.
Well, I have a match today.
Oh, you do?
Yeah.
Is it home?
Yeah, it's against Wayne.
Cool.
Yeah, see, I work today from 4 to 7, tomorrow and Saturday from 10 to 2, and then 3 hours Monday and Tuesday 4 to 7 again.
Dude, my workplace is so whack. So like I switched jobs, but now like I work 9 hours and don't get to sit down like on break.
That's
Where
whack.
do you work now?
Whack.
Oh, you still work at the bowling alley? Where'd you work before that?
Walmart.
That's whack.
That's my too.
Walmart, literally, I see so many employees just walking around for like 2 hours on their phone. Don't ask why I know it's been 2 hours though.
Whack-a-doodle
That means
do.
you want us to ask why it's
Oh,
Rachel, must be a good book. Let's read. It is a good book? What is it really?
Oh, dude, I do that all the time.
Is it
I want more
required
stuff
for
than-
school?
No,
Is it
definitely not.
just for enjoyment purposes?
Yes.
And I spent money on like.
You know, that's good because a lot of people do not read for enjoyment.
Mr. Snyder.
What?
What's one store that you could just spend a whole day in and never do work?
A whole day?
Or like, okay, how about like,
What genre? I mean, there's, I'm literally, like, my team
Well,
is
and it can't be
The
like,
first one that
it
comes-
can't be IKEA though.
No, the first one that comes to mind is Jungle Gyms. Okay, but that, since it's not close by, that would be like this. I would plan on that if I was going to drive down there.
Yeah, so that is not, yeah.
Right. So around here, to tell you the truth, you could drop me off in Home Depot or Lowe's, and I could spend a lot of time.
Oh, yeah, I kind of guessed that one.
Yeah, Cabela's, I could spend a long time at Cabela's as well.
There's like
Yep.
different tiers.
I like looking at the
Yeah,
fish.
it's
I
just
can
like-
identify all of them.
Nice.
No, I feel like.
Have you tried to go fishing yet, there?
Realistic.
Just like cast a line over into the tank and just see.
It's not allowed.
It's not. Hello. Go try it and find out, Abby.
Free
She's
trial.
like, I caught a fish, yeah, and you kind of think like,
Oh my goodness.
yeah,
You
I
see
could
that
stay
on
in
the news?
Walmart all day.
Really?
Oh my gosh.
Walmart is not a place I
I
can spend a
go
long
through
time.
every aisle. Me and my dad found, did I say that we found that ping pong table for $20 and it
What?
retail $100?
Did you buy it?
Yeah, we got 2.
You bought 2 ping pong tables, so you made your court like extra long?
One for us and one for his girlfriend.
Oh, I thought maybe you just like put them end to end, so or extra wide, you could play doubles.
Oh no, but he has this like,
Hurt your
I think it's
head.
called Bricksons. It's a website and it's a QR scanner.
Your
So if
brain
you
is a
scan
lot better at
codes of
making
certain items,
detailed.
it'll tell you what the actual
Images.
detail is. So
Cool.
we did it on
And
the
like
table, just like be funny
inner
about it, 'cause we
thoughts
didn't know, and
that
it ran.
producers are, because the thing with books is when
You
That's
can buy like a
cool.
$680 TV for like $80.
the characters feel, like you
Oh.
can't really like see inside.
What if I can get a
really necessarily.
one-way mirror
Really
for cheap?
Where can you even buy those?
I don't know.
on the right.
I don't really want to know. I'm just joking.
Go to a police department.
Yeah, exactly. I'll do that on my computer here. No one will think anything weird of me then. Mr. Snyder is looking up one-way mirrors. What is up with that?
Just say,
Today is February 5th. It's a Friday.
It's a Friday. Tomorrow.
Today's a Friday. It's February 5th.
Terrified. I'm so scared.
Didn't you just say what is today or something like that?
I'm so scared.
Or today is, you something like that?
26.
No.
Don't lie to me.
I did not.
Maddie,
I
I
don't
will
even know
become
what I said.
very
No,
mad
that's
if you continue to lie to me like that. There'll be
All
2 Maddies in here before you know it. And I will be maddier than you.
All
right. That's what we're for. We're here to make dad jokes.
My dad's only 38, he still makes them left and right.
38.
Yeah, my mom's 34.
My dad's
Students and staff, pardon the interruption. At this time, we need freshmen who are getting their pictures retaken with last names L through Z to head to the auditorium lobby, please. Again, that's all your 9th graders who are getting their pictures retaken, last names L through Z.
All right. So usually I would take volunteers. This time I'm just going to call on individuals, and I'm going to find 3 people, and I'm hoping that those 2 people all probably maybe do something different to start off. Donovan, what'd you do first?
I converted the cubic root into a fraction exponent.
Rational exponent? Oh, so you wrote this then.
Yeah.
Okay, nobody else can say that one now. Audrey, is that what you did? What'd you do?
I rewrote it as an exponent.
You went to exponential form. So you wrote 5 to the second power equals the cube root of 12. Okay? Hey, man, nothing wrong with either one of those. Okay, something different. Chloe, how about you? Did you do either one of those?
Yeah, I did the first one.
You did the first one? How about you, Timothy? Did you do either one of those? You did the second one. Rachel? Lane? Hamza? You did the first. Alexander? You got Savannah? Sarah? Oh my good. Ali?
Second.
Maddie? Abby. You're the last one. That's why I said it like that. You did this. Really?
Yeah, you said.
I don't want to hear from you, Seth.
Oh, dang.
Then I have to unmute myself and hear us talking right now in 3 seconds, and I don't want to hear myself talking again in 3 seconds from now, and him talking. This is nonsense. Sorry, Yusef. Love you, bud. All right, so, well, I guess it's okay if you guys just went those 2 routes.
I don't understand how there could be a third one, but okay.
What's that?
25.
Well, I just put down in case we need a 3rd route. I mean, I'm sure there is.
And you should probably found it, but.
Well, Yusef finds everything. So we'll just go with these. It's fine, because I won't introduce something new and just to confuse you. That's not nice. So let's do this. If I go this route, what would be a good next step then?
Which route?
The green.
Turning it into exponential.
I could. What else could I do?
Wait, how does that even work? Or am I talking?
What else could I do on the green one if I did not want to go to an exponent yet?
You also could have done 12, figured out what 12 to the 1/5 power is.
That would probably be a decimal.
Power to a power?
Not power,
Power
the power property
of
for
logarithm.
logarithms. I could kick that 1/3 out in front like that if I wanted to. That's a possibility. Do you have to do that? No. You don't have to. Okay? So now if I do this, what would be my next step? Actually, let's do this. Let's take this and we'll go multiple routes with this. Because everybody here told me to do what? Write it as 5 squared equals 12 to the 1/3. Is that what you guys wanted me to do? Yeah? Okay. So over here, what would I do next? Because they're going to be the same. The answers will be equivalent. What would I do in the green one? Yeah.
Could you put the entire logarithm over 3?
I could. How can I get rid of multiplying by 1/3? Divide by 1/3, which is multiply by 3 on both sides. What would happen? I'd get log base 5 of 12 equals 6. Right? If I multiply both sides by 3. Now I go exponential. What do I get? Where did my x go? Wait, there's supposed to be an x in this.
There wasn't.
No, it's supposed to be in here. X.
Oh my God.
That means this. Oh, see, I was like, what? And then this would be this.
I was wondering.
And this would be, yeah, we gotta go back. Back up!
God.
Start over.
All the econ was taken.
All right. This was the original problem. I got so excited earlier, I just messed up. I think actually I'm just like low on oxygen right now from this mask being on. Who knows who Mr. Shirley is?
I do.
So Mr. Shirley teaches down the hall, he teaches anatomy physiology. And he's got a pulse oximeter in there, which tests your oxygen saturation level in your body. And if you go ahead and you go, like, have you ever had that thing that's clamped on your finger?
Yeah.
And usually if it just a normal, if everything is okay, you're usually like somewhere in like 97, 98, 99 saturation, okay? So he put it on at the beginning of the day, of a period actually, and before he had his mask on, he took his blood sat and it was a 99%, which is great. He taught with this on all period, went over and took it, 95. because you're being oxygen deprived somewhat by this. So it really does. And then we've both been saying that your mind, when you have less oxygen, your brain doesn't function as well. So I have a little patience with you. If you guys mess up, I'm okay with that. I'll just mark it wrong. Okay, so here we go, guys. So now that I have the problem here correctly, let's go ahead and we're just going to go the same two paths we kind of had before. Most likely you would start the same way. So let's go this way, and we're just going to go ahead and rewrite it as an exponent that's rational instead. So this would be one possibility. Here's the x. It's right there. I just didn't write it dark enough. Okay. And then the other possibility would just go straight into exponential form, and that would be 5 to the second equals the cube root of 12x. Okay. Now, at this point in time, if I'm doing the red one, I could go two different ways. I could put this 1/3 out in front. Let's say somebody chooses to do that. They're going to kick the 1/3 out in front. So it's 1/3 times log base 5 of 12x equals 2. Now they might do what next? Multiply both sides by 3. And they're going to get log base 5 of 12x equals 6. And then they're going to go to exponential form and say 5 to the 6th power equals 12x. So x would be 5 to the 6th power over 12. Boom, got it. All right? This person over here, if you're doing this, I'm just curious, what do you think most people would do next here?
Square.
Most people would probably replace 5 squared with what? 25. How many of you would do that? Just be honest. Yeah, so let's do that. Now I would do what? Cube both sides. So I get 25 cubed equals 12x. And then I would divide by. Now, here I have two answers that are equivalent, but they don't look exactly the same. But they are the same, because I know over here 25 really was what? 5 squared, and 5 squared cubed is 5 to the 6th. Would I accept them both? Of course I would. I wouldn't care which answer you gave me. They're both fine. They're both exact. So I want you to understand, different paths to the same answer or different paths to answers that are equivalent. So if you and your friends are doing problems over the weekend and you contact each other and you don't have what sounds like the same answer, you may have the same answers. You may. Don't freak out. Okay. All right. That's this. All right, let's ratchet it up a notch here. Enough of this child's play. Okay. So this one's different now. So here on this one, we would actually need to do something. I've got two logarithms being added equal to some constant term 2. Before I can rewrite as an exponent, I have to get down to one logarithm. So this is a scenario where I have to apply the property called the product property of logarithms. I would have to rewrite this. So that's the one big difference is I have to have, if I have multiple ones together, I have to condense before I can go to exponential form. So this would become log base 5. What do I do with the x plus 4 and the x plus 1? I'm going to multiply them. Now, I'm going to actually multiply them and put the product here. I'm not going to leave it as x plus 4 and x plus 1. I'm going to need to multiply out anyways. Let's just do it now. X times x is x squared, plus x plus 4x is plus 5x, plus 4. Now we'll write it as an exponent. So 5 squared equals x squared plus 5x plus 4. So now I'm not solving anything other than a quadratic. Oh, yeah, that's fine. So I'm going to get, if I subtract 25 from both sides, I'm going to get x squared plus 5x minus 21 equals 0. Solving quadratics. What am I going to do? If I could factor it, that'd be great. Do I have anything that multiplies to negative 21 and adds up to 5?
No.
Nope. That means my only option is what? The quadratic formula. Now, before I go any further, I want to go back up here. I'm going to write a question I want you guys to think about. Don't say it. I will ask somebody. Okay? Okay? Yeah. Yeah, because it's pointing down. For that equation, what must be true about good values of x? Who wants to help me out? Come on, somebody help me out. Somebody that doesn't usually help me out. Well, let's talk up here. What has to be true about this entire thing?
No, I'm getting wrong.
Okay, wait. Let me ask my question. Answer this one first. What has to be true about log base 5 of this entire, what has to be true about this entire blue rectangle? Chloe? Has to be positive. How do I write that as an inequality? Greater than 0. So I know right here that x plus 4 is greater than 0, which means x has to be greater than. Okay, now the other one over here, what's going to happen? X plus 1 has to be greater than 0, which means x has to be greater than negative 1. So if I look at those side by side, in general then, in order for my solution to work in both pieces of this, x has to be greater than what? This. Okay, now, I did that for a reason. Down here, I know my answers are not going to be like nice, neat numbers. If I'm using the quadratic formula hidden factor, I'm going to get like probably radicals. So if I'm good at estimating, I will know if it works or not because I know what my estimate needs to be. So now we're going to keep going with this problem. Let's keep going. Here we go. X equals negative b plus minus square root of b squared minus 4 times a times c all over 2a. In here, you're going to get 25 plus 84. Okay, so I'm going to stop, make sure we're okay where I'm at right now before I go any further. Remember, this is A, that's B, that's C. So far, so good? We're good? All right. Now, so my two solutions right now are Okay, square root of 109 has to be a little bit more than what? Has to be a little bit more than square root of 109
Oh,
needs to be a little bit more than 10. 10 squared is 100. Okay? So let's go right over here and start with this. If it was 10, it'd be 5, negative 5 minus 10. Negative 15 divided by 2 is negative 7.5. Is that going to work?
no.
Not a chance. That's an extraneous solution. No way. This one. This, we said, was going to be what? About 10. 10 minus 5 is positive 5. So it's going to be about 2.5.
Yes.
I like it. That's good then. Did I even have to use my calculator to get an idea if they were going to work? No. Now, if it was really close, then I might have to say, oh, I'm going to actually check it. I mean, you potentially could get something that was close, I guess, but a lot of times you can estimate and know if it's good or bad. All right. So on a scale of difficulty, is that a little bit more? Yes, because you had to combine them first. You had to square, you had to use the quadratic formula, you had to check your answers. So there's a little bit more involved in that problem. That is not nearly the hardest type of problem, though. Here we go. Let's try this one. This is going to kind of look like that one earlier when somebody said, what happens if you can't make them the same base? Is that you, Hamza?
That was Hamza.
Hamza. So here, Hamza, this is kind of like what you asked about earlier, remember? Here we go. 2 to the 3x equals. Now, the one we did earlier where I had two numbers on both sides was 11 to the 5x equals 33. Only one side had an exponent with the variable. Now I've got both sides, variable and the exponents, and the bases are different, and I can't make them the same. More difficult. So I want everyone now, just write anything you want to do for the first step. Just write down what you think you could do for a first step. Just write something down. I mean, there's multiple possibilities you could do. Is anyone bold, willing to tell me what they did in their first step? Alexander, what'd you do?
I just looked at it and I tried to figure out mostly, but I forgot. I wrote it down.
Oxygen deprivation. Anybody? Hamza, what do you think?
3x equals x minus 1. Even though the bases aren't the same, they're still equal.
Oh, is that true? If these aren't the same, can I say these have to be the same if these aren't the same? I don't think I can say that. I wish I could. Yeah.
I said log base 2 of 3x minus 1 equals 3x.
3 to the x minus 1, is that what she said?
Yeah.
Okay. So she went ahead and rewrote it as a logarithm. And what she chose was to make this the base. So think of this as 2 to the x equals y, in other words. It'd be log base 2 of y equals x. So she wrote log base 2 of this entire thing, 3 to the x minus 1 equals 3x. Okay? That is completely okay. There's nothing wrong with that. Now, if I could use 2 as the base, I probably could have just used what as the base instead? 3. I probably could do it the other way instead if I wanted. I mean, guess I could just say, oh, well, log base 3 of 2 to the 3x equals what? X minus 1. All right? Both of those are just going from exponential to logarithmic form. Okay? I like those both. Now, they're both kind of approaching it the same way, technique-wise. Let's go ahead and, oh, I don't know. Which side do I want to use? Boy, I don't know. Let's use the left hand. Let's use the blue one. Let's use the blue. I'm going to continue with this one over here. What do you think I'm going to do next on this?
Move x minus 1 to the front of the
I love that idea. X minus 1 times log base 2 of 3 equals 3 to the x. I have to be very careful. Everyone look. I do not like the way I've written this on purpose. This looks like x minus 1 times this. X minus 1, the entire thing is being multiplied by it. So I want to put it in. Okay, parentheses are so important to understand what's really happening, because that was the exponent. Now, I know that whenever I have equations and I have the variable on both sides, I have to get the variable on one side somehow. At this point in time, on the left, I am going to distribute log base 2 of 3 through the parentheses. I'm going to distribute it through. So here I'm going to get what? X times log base 2 of 3 minus log base 2 of 3 equals 3x. Is everybody okay with what I just did? I distributed log base 2 of 3 through the parentheses to get this. Now I want to get my x's on one side. Okay, if I divide by a variable, I will lose it and I have nothing left to work with. Well, I have, this one's already by itself. I would like to get this one over there. Minus what? Log base 2 of 3, what? I'm going to minus this piece right here. I'm going to minus x times log base 2 of 3. Cancel out. I'm left with negative log base 2 of 3 equals 3x minus x times log base 2 of 3. On the right-hand side, guess what I can factor out? I have 2 x's. I only want 1. So guess what? I factor out the x. Now what I can do? I can get x by itself by dividing by what's in the quantity. I divide by what's in the quantity. Divide by 3 minus log base 2 of 3. Divide by 3 minus log base 2 of 3. Cancels. I'm left with this. X equals negative log base 2 3 over 3 minus log base 2 of 3. Isn't that beautiful? And you're going, what? Okay, now, are you ready? I'm going to do the same problem again. I'm going to do it again. Because I just told you guys your answers could look so different and they're the same. Before I do this problem again, anybody want to ask anything about this? I know there's kind of a lot going on there. I'm going to go back here real fast. Towards the beginning, I put down this right here. And you all understood this green thing I put up here, right? We're all okay with that? So if I gave you this, this is true. If I gave you this, this is true. I mean, either way, you should be able to tell me it's okay. 2 to the 3x, 3 to the x minus 1. Okay. Here's how I'm going to approach it this time. I'm going to take a logarithm of both sides. And I can choose any logarithm I want. I'm going to choose this. Is that okay? What I've just done, I've taken log base 3 of both sides. What happens on the right-hand side? It's just x minus 1. Remember when it's log, remember what we had? We had this, log base b of b to the x was equal to x. Now I chose base 3. I could have just as easily chosen base 2 and had this cancel out on this side. I just chose base 3 instead. So what am I going to get? I get log base 3 of 2 to the 3x equals x minus 1. Okay, I like that. Now guess what I'm going to do? Now, don't freak out here. Don't freak out. Log base 3 of 8 to the x equals x minus 1. What just happened? Yeah, remember, this 2 to the 3x is 2 to the 3 raised to the x. I just kind of did it in my head using power of a power. So now I'm here. Now what am I going to do with the x? Kick it out in front. Now again, I want to get my x's on the same side. So I get x times log base 3 of 8 minus x. These are not in parentheses. So this is not included. They're not together, right? Factor out the x. Now do what? Divide by that thing. Oh, figure that out. Those two things, those are equivalent. So you call your friend and you say you got this, they say they got this. Hey, babe, that's right, you got it. They don't look the same, but they are the same. Oh, yeah. So that's why there's a lot of freedom in solving things, guys. There's a lot of correct paths. Okay, so both of those would be good. Now, again, that means in order for me to really have a good idea what you've done, this is what I need to be seeing. It allows me to know if your answer is equivalent without just punching it into the calculator. I'd rather be able to do that. What time are we going? 15. Yes, we got plenty of time. All right, last problem. By the way, all of this will be posted online for you. And I know you're sad this is the last problem. You wish we were doing about another 5 or 10. But I'm sorry, I only have one more written down here. Here we go. So the last problem I gave you, I had exponential where both of the bases were different. Let's do logarithms where both bases are different. Okay. Woo! Well. I wish they were, I mean, wouldn't it be nice if that was just a log base 9 and then I could make this x equals 6x?
Hold up.
What?
I'm looking at this.
Well, that's good. I hope you are.
Well,
Means your eyes are open.
isn't 9 just a square root of 3?
9 to me is 3 squared. I know oxygen deprivation. I understand.
Yeah, no, 9 equals.
9 is 3 squared. 3 is the square root of 9. I know. Do this for a second. Okay, I feel better. There we go. So yeah, last period somebody said, well, Mr. Snyder, can I do this if I wanted? Is this okay to write this? Now they're both base 3. Well, are they really base 3? No. That's what you're thinking. You're thinking, I understand your thinking right there. It's not bad thinking, but we've never made this something like that. That's kind of bizarre, but I don't know, maybe I could do that. That'd be kind of crazy. Or is it crazy?
I don't think it is.
I mean, I've been called crazy. I've done crazy things. Can anybody tell me what Cobb says? What's Cobb?
Changing of base.
Change of base. This problem right here, this log base 3 of x, that's the same as the common log of x over the common log of 3, or it's the natural log of x over the natural log of 3. As a matter of fact, it's log base b of x over log base b of 3. As long as those bases are the same, that's what change of base formula says. Well, guess what? I'm going to use base 9 for b. I'm going to change the base of this. I'm going to write log base 3 of x is equal to log base 9 of x over log base 9 of 3. And now this is equal to log base 9 of 6x, which is over 1. Everything now is in base 9. Everything's in base 9 now. Oh, okay. Hey, you know what? This right here, oh, whoa. Is that not a bit about not what I wanted? Nobody go. Ignore that. Isn't this the same as this?
Yes.
Isn't 3 9 to the 1/2 power?
Yes.
So
He's gone too pro. He's gone pro.
so wait, what's going on here now? What am I going to get on the left-hand side? What's the denominator going to be? What am I going to get down here? Log base 9 of 9 to the 1/2 is what?
1/2.
1/2. Remember, the base is the same. The answer is the exponent. So now I get log base 9 of x over 1/2 equals log base 9 of 6x. Can somebody simplify the left-hand side? Is there anything I can do with that? Dividing by half is what? I mean, I got to be able to simplify this, guys. What if I gave you this? What if I gave you 8 over 1/2? What's the answer to that? How'd you get that?
Put the 10 in the front and then x squared.
Oh!
Turn 6 x equals x squared.
She's saying this is equivalent to this. So this is equivalent to this.
Wow. Did it, guys.
And then Rachel said, put the x up here and make it x squared. And now I can just do what? Set x squared equal to 6x, right? Because they have the same base. That means x squared minus 6x equals 0. That means x times x minus 6 equals 0. Factor. It means x equals 0 and x equals 6. But I know I better make sure those work. 0? Can I put a 0 there?
Yes.
Can you take logarithm of 0? No. Extraneoso 6. Yeah. All right. Now, are you ready? Oh, you better be, because I'm not done with you. I'm just about done with you. Remember this thing I wrote right here? This thing right here. I'm going to just real quick do a little. I don't have time. I do have time, but I don't have time because I got to give you the problems to do tonight. I'd rather do that. Monday, we're going to look at that when we come back. Woo! Oh, come on. You have some idea.
No,
No, I don't.
Look,
No.
if the only one you don't understand is the last two, if those are the only two you're struggling with, don't freak out.
No.
Okay? Those are the hard ones.
I was zoning
I
out.
know. Papier.
I don't even know what's happening in the first section of this chapter.
Okay, guys, here we go. I'm going to tell you which problems to do. If you're not doing all of these. All right? Nope, here we go. On the front. So on the front, you're doing the evens. You're doing 2, 4, 6, 8, and 10. Straightforward. Exact answers. 2, 4, 6, 8, 10 on the front. On the back, you're doing 11, 16, that's on the right, 14 on the bottom left, and I'd like you to try the extra. The extra is a challenge. That's harder. That's like the one that we did in here. Okay? See what you can do with those problems. We will be doing solving equations on Monday again. We'll be doing more problems like this. Thank you so much, guys. Have a great weekend, and I will see you Monday. Or who knows, maybe I'll see you before that. Woo! Bye, Yusef. See you, buddy.
See you.
Thanks, you as well.